Hello, this is Ron Daskovich, and in this video we're going to show you how to implement a linear regression algorithm in Scikit-learn. The first thing we need to do in any machine learning problem is prepare the environment. Here I am in Azure Notebooks, as you can see, and I've opened up a new notebook, and this notebook is called Boston Housing Linear Regression. The first thing we need to do is prepare the environment. As you can see, we're going to import NumPy as MP. We're going to import pandas as PD. I'm not sure we're going to actually use it in this particular example, but it's not a bad thing to have. We're going to import matplotlib pyplot as PLT, and we're going to import sklearn as well. The second step in a machine learning lifecycle is to load the data. So from sklearn.datasets, we're going to import load Boston. Just go ahead and run this particular cell. From sklearn.datasets, we're going to import load Boston. Sklearn has several different datasets that are available for this exact purpose, for playing around with different linear regression algorithms, and algorithms as a total as well. Notice that we're going to implement a Boston dataset variable, and we're going to run the load Boston function from sklearn. And let's go ahead and look at the type of this Boston dataset. So hitting Shift Enter, we'll go ahead and run this cell and move to the next one. So you can see this is a sklearn bunch. And the sklearn bunch kind of works very similar to a dictionary in Python. We can print the keys, we can look at the feature names, and we can look at a description of how the actual dataset looks. Let's explore our data for a little bit. Notice that our dictionary keys include data, target, feature names, description, and file name. Those are the different keys that are available in our bunch. And notice here I've done a Boston dataset feature names. Then we did a Boston dataset description as well, and you can see that here are our different attributes. Our attribute information includes per capita crime, proportion of residential land zone for lots over 25,000 square feet, proportion of non-retail business acres per town, nitric oxides, average number of rooms for dressing, proportion of owner-occupied units built prior to 1940, index of accessibility to radial highways, and you can see what some of the others are here. And our dependent variable here in this case is going to be median value of owner-occupied homes. And that's what's going to be our target here in our data set. Well, I've got a hypothesis that the number of rooms that are in a house is going to affect the median price of that house. Let's go ahead and prepare the data and break it down into the training and test data sets. From sklearn, model selection, we're going to import train and test split. We're going to define number of routes train, number of rooms test, median price train and median price test. Remember, that's going to be our dependent variable. And we're going to implement a train and test split where we're going to look at the fifth element of our dictionary, the fifth column of our dictionary, which is our number of rooms. You can see that here's the attribute information in order. So these are our columns. So this is column number 0, 1, 2, 3, 4, 5. You can see that we're referencing the number of rooms per dwelling as 5. And then the input to our linear regression model is actually looking for a 2-day array. We're going to reshape it into -1 and 1. This tells me keep all of the rows and then organize the data into one column. Well, the only column we're representing is the number of rooms. And then we're going to do a Boston dataset target, which happens to be our median home value in hundreds of thousands. We're going to reshape that one, take all the rows, and implement a column as well. Let's go ahead and look at the shape of each one of these to make sure that we did that correctly. We're going to print the number of runes train.shape, the median price, train.shape. Then we're going to go ahead and look at our number of runes.test shape as well, and look at a particular value in there. So let's go ahead and run this cell. You can see that our training set has 379 rows in one column. You can see that our test set has 127. Notice that in my train and test split, I didn't specify a split, and it automatically splits it 75-25. Let's go ahead and implement our linear regression model now. From sklearn.linear model, we're going to import linear regression. Our price per room is the variable we're going to set to our linear regression model. And let's go ahead and do a fit on our training data. The first argument that goes to our fit is actually the number of rooms. And the second argument that goes to our fit is our median price. We're looking at median price as a function of the number of rooms. Let's implement our linear regression model and then fit our linear regression model to train it. And the next step, of course, is to predict on our linear regression model. We're going to do a price room.predict, number of rooms test 0, and of course to map that or show the output later, we actually want that to be in results per row. And we want one column, so we do want a 2-day array. Let's go ahead and look at a couple of individual results, and then let's go ahead and look at a set of results from a range. And then we're going to go ahead and do the prediction on the entire test set as well. Notice that we're going to do a med price prediction, price room, which is the model, predict, and we're going to predict on the number of rooms test. Here's the output of 0. Here's the output of 5. So the fifth element. And here's the output of the first 10. And let's go ahead and graph the results. We're going to import matplotlib pyplot as plt. We're going to plot our training data, and we're going to turn it green. We're going to plot our test data, and we're going to turn it red. And we're going to plot our prediction and name it blue. Remember, the first argument is our x-axis, and the second argument is our y-axis. And then we're going to go ahead and plot the regression line as well, which is what this particular statement does. So plt.plot number of rooms test, price room.predict number of rooms test, and the color we're going to specify on the line is gray. We can go ahead and specify a title for the graph. We can also provide labels for the x and the y-axis. And to show all of this, we can go ahead and do a plt.show. So remember, the greens are our training data. The reds are our test data. The blues, which are actually on this regression line, of course, now, right here on the graph. And then we've got the actual regression line, which is in gray. And congratulations, you've just done your first linear regression model.